Cool. Hello, everyone. Welcome to Synergetics Livestream number 5.0. Today is February 7th, 2021. I'm Daniel Ari Friedman, and looking forward to today's discussion because we're going to be hitting some great topics. Today in Synergetics Livestream 5.0, the spirit for today is family, navigation, and paradox. So family, just always important and something really powerful and something that embeds throughout life in so many different ways. Navigation, at the heart of words like cybernetics, or you could say that they're related topics. Bucky's grave, call me trim tab. This idea of navigating is something that's central to life and active inference, as well as central to just synergetics. And then the last one is paradox. Reminds me of a saying by my colleague Scott David. He said, or at least he said that he told his children that when they were encountering paradox is when they were encountering truth. So that was really powerful, and paradox is also something pretty interesting and maybe something that is related to synergetics or not. All right, today in 5.0, we're going to go over our key memes and themes and our things to integrate, and then we're going to get to the text. And the text, we're going to have two longer sections. The first is 620 Tetrahedron, and the second's going to be 986, the Demass Model, which was recommended by CJ in the Reading Synergetics piece that we looked at last week. And especially for tetrahedra, I'm excited because I actually have 3+ tetrahedra here that we're going to look at. This is a brass tetrahedra that one of my college roommates, Trevor, made for me during a metal casting class that he was taking. So thanks a lot, Trevor. I look at it every day. This is a small tet that is made up of springs that are just connected without any joints, and it can be flipped inside and outside, which we'll kind of do. And then also I have a few of these bigger tetrahedra, which are made of slamming door, sliding door, or screen door springs. Pretty strong, pretty cheap, and then carabiners on the end. And so it can be folded up for storage, for travel. And then it unzips back into a tet. So we'll kind of get to those. And then, of course, the stack of Bucky books. So let me flip back this tet. Put it on the books. All right. First to the key memes and themes. So just to kind of go through them and remind ourselves, get those neural ensembles cranking, reminding ourselves of all the things that synergetics makes contact with in our own experience and in abstractions as well. So synergetics is relational and multi-scale thinking. It's a lot like complexity. Synergetics is connected to our accessible experience, even if it's related to our experience of thought or just personality. It doesn't need to be our experience like with holding something, but then it turns out that especially because tensegrity is so tactile and so force-directed, it actually lends itself not just to thinking in terms of physical abstractions like tension and compression. It's actually something we can learn from and kind of stigmergically modify our tensegrity niche. Synergetics doesn't really believe in the infinitesimally small or the infinitely large, nor points, lines, and planes. So as for why are there no things that are infinitely small or large? Because things that are infinitely small just don't exist. Things have to exist if they're physical, though they can be metaphysical and be vanishingly small. And similarly, for large things, even universe, which is just the total scenario, the total set of everything, even that is finite, according to Bucky. Perhaps someone could disagree on that. And then points, lines, and planes, things that are 0, 1, or 2-dimensional, they don't actually exist. They don't enclose space. They don't project volume. And so they can't exist physically. Again, they can exist metaphysically. In synergetics, we think about design as an anticipatory cybernetic science that exists to realize a better world for everybody. It's about the abundance that we can realize through better design and anticipating design. In synergetics, there's a relationship between abstract and engineering, or theoretical and applied, just like there is kind of like between physics and engineering. So synergetics is kind of like physics. There's math, there's geometry, there's fractals and symmetries and weird stuff like that, crystals. And then tensegrity is a lot like engineering because it actually relies on making physical objects. I need to clean my desk. In synergetics, the universe is the total scenario. It's the total set of everything that's out there. And then the subsystem is just any system that's smaller than universe is going to be a system or a subsystem. And you don't need to say the universe because there's only universe. And we think about 4D a lot, 4D as four-dimensional, but also 4D time lock, Project 4D time lock. And Project 4D, a few things are relevant about it. So one thing is that it can refer to the tetrahedral focus, which we're going to talk a lot about today, which is why it'll be fun, instead of the square focus or the orthogonality of 90 degrees. But there's other meanings of four-dimensional, and so I just really like this slide by Kirby Erner, where it mentions 4D as polytopes, Coxeter, and extended Euclideanism, which is kind of like a higher dimensional geometry. Then there's 4D as relativity Einstein, which is kind of like 3 spatial dimensions and time, which is also related to tensors and computer science and objects like a matrix that changes through time. So it's like a cube that changes through time. So it's a hypercube. And then there's this very first principles understanding of the tetrahedron as the minimal shape, which is kind of a purely Bucky innovation, but of course has its roots in earlier tetrahedral cults. So that's actually it for the memes and themes. Haven't really added anything to the things to integrate, but we took Demass scenario off of here. That was put there after we read CJ's piece about reading Synergetics. And also today it'll be fun to think about back to, from Kelly Ritchie's tetrahedral perspective of kind of the tet, in, out, not up and down, in and out, like the restaurant, and then around in between, in the past, present, and the future, and where does identity, where does system integrity, pattern integrity come into play. But let's get there by reading the text. So here we go to section 620, tetrahedron. So as usual, we'll read the section verbatim, then read it interspersed with some quick thoughts or definitions, then think about an example in a question, which will be very nice because, again, we'll have the physical tets on hand. So 620.0, then part 1. In the conceptual process of developing the disciplines for carrying on the process of consideration, the process of temporarily putting aside the irrelevancies and working more closely for the relationships between the components that are considered relevant, we find that a geometry of configuration emerges from our awareness of the minimum considered components. A minimum constellation emerges from our preoccupation with getting rid of the irrelevancies. The geometry appears out of pure conceptuality. We dismiss the irrelevancies in the search for understanding, and we finally come down to the minimum set that may form a system to divide universe into a macrocosm and a microcosm, which is a set of 4 items of consideration. The minimum consideration is a 4-star affair that is tetrahedral. Between the 4 stars that form the vertexes of the tetrahedron, which is the simplest system in universe, there are 6 edges that constitute all possible relationships between those 4 stars. All right. This is where we start going into the rationale, or at least the experience of the downstream commitments from deciding that tetrahedral was going to be central to Synergetics, however that happened to be. We're going to start, as Bucky often does, with a psychological consideration of why things are. So it's appealing to our direct experience or our imagined experience, whether it's a thought experiment or sci-fi or a history or a fable. So what we're doing in Synergetics, which is the geometry of thinking, we are in the conceptual process of thinking about what to think about. We're deciding how we're going to have discipline and rigor. So for various reasons, like reproducibility and accessibility of our pipeline of thinking, we want to be, and so basically making the pedagogy central to the material. So we're thinking about how to develop the disciplines. And also that's related to this process of putting aside the irrelevancies. So there's so many systems you could draw. The neck bone, it's connected to the shoulder bone and the backbone, and there's blood and there's nerves. So there's so many ways you can go with making a model of a given situation that really the onus is on the thinker, the sense maker, to be dismissing irrelevancies. You want to get down to the relationships between the components that are considered relevant. This drug is going to attack this protein and it's going to bind to it in this way. And so that can be, we can dismiss all the other proteins if it doesn't bind to it, for example. But of course, if you make an error and you dismiss things that are relevant as irrelevant, your model might be too narrow. And so it might be a very fragile or an ineffective model. For example, if you say, well, this drug binds to this protein, so now we're done looking across the rest of the genome, maybe there's another protein it also affects, or there's a downstream signaling consequence. So you can't just only focus on a one or two relationships, because often you're going to not capture these more nuanced feedback systems that natural systems are involved in. We find that a geometry of configuration emerges from our awareness. So again, it's centering our direct experience of these systems. It's not saying the systems are tetrahedral and the minimal causal loop is 4. It's saying it's our awareness about system modeling. So it's kind of like instrumentalism. The minimum considered components. A minimum constellation emerges from our preoccupation with getting rid of the irrelevancies. So in fact, it's not just our imperative to dismiss the irrelevancies, it's actually our preoccupation, and it's our occupation as well. And so the geometry is arising out of thought, because it's not like by thinking about a system in terms of a tetrahedra, you make this little thing show up on scene. It's more like happening in thought or in the thinking process that geometry is arising to abstract away from, well, yes, this is a plant and a fungus and an animal, but we're going to think about it in relationship to a fourth something, and that's going to be a tetrahedron. So that's conceptual. We dismiss the irrelevancies in the search for understanding, and we finally come down to the minimum set that may form a system to divide universe into macrocosm and microcosm, which is a set of 4 items. So with 4 items that are connected by relationships and edges, so topology, network theory, you make the first space enclosing or volume projecting shape. It's the first 3D shape, is the tetrahedron. It has the fewest number of vertices of any 3D shape. And so anything less than that doesn't enclose space. It doesn't have physical existence. It's like a triangle or a line or a point. They're all abstractions, so they're cool in our mind, which is metaphysical and doesn't need a physical component, but they aren't going to be something that you can physically hold, so they're not part of the physical strategy of objects. And the macrocosm is everything outside, and the microcosm is everything inside. So to have in and out, the geometry, not in the reference point, not just the restaurant, you need macrocosm and microcosm to be separated by this tetrahedral interface. It turns out that that minimum number is 4, and that's the shape that we call the tetrahedron. And between the 4 stars that form the vertexes of the tetrahedron, that's related to this book Tetrascroll, where the stars are talked about as tetrahedron, but these 4 points on this tet are all happening at the same time, right? They're all in the same moment related to each other like a tetrahedron. But then think about you observing the tetrahedra stars. 1, 2, 3 stars, and then you. So those stars are sending light at a speed that's not instantaneous. It's actually taking a little while to get to you, or a long while to get to you. And so it turns out that the tetrahedra isn't just the 4 points at once. The tetrahedra is also the 4 points through time where their bubbles intersect. So it's like 4 lightning strikes, or 3 lightning strikes in an observer, or 1 lightning strike and 3 observers, whatever it happens to be. That tetrahedron is something that is finite, and it is something happening through time. So a tetrahedra doesn't have to be happening all at once, which is kind of one of the main divergences between tensegrity and synergetics. I'll leave it at that for now, but that's one of the main divergences, is that synergetics can include these through-time relationships, whereas tensegrity, as the instantaneous structural stability demonstrates, the geometric relationships are actually, they can change through time, but instantaneously they do have certain shapes. Again, tetrahedron is the simplest system in the universe, and there's 6 edges that constitute all the possible relationships between those 4 stars. And just one thought on this, because this first section's so key, before we maybe go a little faster, or we'll see how it takes. But tetrahedron appeals to 4 sides. A hedra is a face. So that's the way that the Greeks named it, or the way that the Greek etymology has coursed down to us today, is tetrahedron. But there's a few other things that we could call it. One of them would be prioritizing the edge. So a truly relational, or a relation-first ideology would say it's a hexa edge. Now maybe there's other hexa edges, but there could be some other word. The point is it's a hexa edge, one of them. Maybe it's the only one, I don't know. And then another way to call it, which would be prioritizing the vertex or the stars, would be calling it a tetravert, which sounds like a kind of person, but actually it could just be tetra vertices. And from a discussion that we had over this weekend, perhaps some people have tried to use tetravert in I guess, a conversational context. But the way that we're going to think about it in synergetics is actually as a univol. It has a uni volume, or it's that in and out relationship. And it has a volume of 1. Bucky kind of rescales reality so that the volume inside of the tet is 1. So instead of the current SI units, it's like you got 1 meter, or you got 1 centimeter cubed is 3 90-degree angles. That's, if it's water at 4 degrees, that's 1 gram. It takes 1 calorie or 1 kilojoule to heat it up a very specific amount at a certain temperature. So it has a certain mass, certain volume, certain dimensions. It's tethered to water as a physical reference point. There's other reference points too. But the cube is actually implicit in the SI system. Now, we'll see how you can also get powers and square roots and all these things through synergetics probably another time. But think about this as having a volume or a weight of water of just 1. So the tet is the univol, because it's like, why would the cube be taken as a volume of 1 times 1 times 1, when it is clearly a little bit bigger than the smallest volume? That's part of the thinking around the tetrahedron, is since this is where volume starts to exist, it's the simplest physical existing thing, then it should have the reference. It should be, the astronomical unit is like Earth to the sun, or, whatever fiat currency is currently du jour. It's like 1, that's like the reference point. So shouldn't the tet be the reference point for volume? And in synergetics, it is. So the volumes are calculated a little bit differently depending on how deep you go. The tetrahedra occurs conceptually independent of events and independent of relative size. So the reason why is that physical objects have size. They must actually exist in space and in time. Whereas metaphysically, things like a triangle, which is the relationship of 3 things, can be of different sizes or different kinds of things, because it's about the 3 things being related. And so the tetrahedra is a metaphysical thing that we're not saying is constructed in the world, but there are tets out there. It's actually like there's the total constellations that we could look at, all the stars in the sky, and then we trace out 1, and then that's the minimal system. If you trace out only 3, you don't have a tet. But if you look at all the stars, you trace out 4, now you have the minimal system as defined by the observer, which is why so often in synergetics modeling, we do 3 things in the system and then us as the observer, because it's a way to formalize a relationship between the observer and the self. And you can go really down that rabbit hole with thinking about, just you and the system, and then the other 2 could be other things that aren't even interfacing with the system. So that actually centers the navigator or the investigator in a pretty different way. By tetrahedron, section 3, we mean the minimal thinkable set that would subdivide universe and have interconnectedness where it comes back on itself. The 4 points have 6 interrelatednesses. There are 2 kinds of number systems involved, 4 being prime number 2 and 6 being prime number 3. So there are 2 very important kinds of oscillating quantities number-wise, and they begin to generate all kinds of fundamentally useful mathematics. The basic structural unit of physical universe quantation, tetrahedron has the fundamental prime number oneness. All right. So by tetrahedron, we mean the minimal thinkable set. So again, we're dismissing irrelevancies. We're converging, distilling down to this core tet minimal thinkable set. And it is the one where you start to get a subdivision of outside the system and inside the system. And it comes into existence volumetrically at the same time when you add that 6th edge, or when you add that 4th all associated point. So it's kind of all happening at once, but we're going to prioritize that volumetric component of the tet coming into existence, rather than being like, whoa, when you add the 4th point, you get a 4th one. It's like, when you get the 4th point, 1 plus 1 plus 1 plus 1 equals 1. The 4 points have 6 interrelatednesses. So 4 vertices, and then they have 6 edges. So I needed 6 springs to make this tet. And also there's the inversion aspect of the wireframe one. And so there can be a system that's oscillating like this. And I don't know what section in Synergetics it is, but it's a tet that looks like this. And then basically it inverts. And so it flips inside outside. And then you have a tet going the other direction. And then it can also oscillate. So it's like 3 that are stable. And then this one can go back and forth. And so that powers a lot of the dynamics, I think. All right. So the 4 points have 6 interrelatednesses, or the way that we might say it in just regular graph theory would be like the 4 nodes have 6 edges relating them. There are 2 kinds of number systems involved. Okay, number system is probably not being used in a technical sense that is how it might be used in the outside, but I think this will make sense. 4 being prime number 2 and 6 being prime number 3. So there's basically 1, which is the first prime number. That's the volume, that's tet existing is 1. Then we also want to hit some of these low primes. So first there's 2 and then there's 3. 4 is not a prime. We can get 4 by 2 by 2. So we don't need to explain 4. And then once you get to 5, you're already like way past the minimum system. So really we want to get at this 2 and 3. So we got the 1 from the volume. Then we have 4 being prime number 2, which is like the 2ness is arising from the, so we have the tetrahedron, which is a hexa edge and a tetravert. So the hexa edge is 2 times 3. And so the things that are associated with 4, which is the tetrahedron and the tetravert, those are related to really 2 times 2. And because 4 is how you get 2. There's probably more to say about that or different perspective, but basically we get the 2ness, the prime 2ness from the tetrahedra and the tetravert, and then we get the prime 3ness from the hexa edge, which is like 2 times 3. And then, so that's the 6. So there are 2 very important kinds of oscillating quantities number-wise, and they begin to generate all kinds of fundamentally useful mathematics. It's kind of like you need a little symmetry break between 0, 1, 2, and 3. So we got the break between 0 and 1. You know, Peter Thiel from 0 to 1, right? 0 to 1 tet, 0 to 1 volume. You go from 0 to 1 when you make the tet. And when you make the tet, in an instant, you get 1 as the volume, you get some 2s, and you get some 3s. So the action, reaction, resultant, the zigzag, which we're going to look at in the next slide, like you get some 3s, you get some 2s, you get some 1s. And once you have 1, 2, and 3, you can pretty much make the 5 with the 2 and a 3, and you can make the 6, of course, with the 2 times 3. So then you're off because you can make anything with the finiteness. So that's why in synergetics, the basic structural unit of physical universe quantation, the tet, has a fundamental prime number of 1. So where did the 1 come into play? With the volume. That's why we reindex everything not around the cube, but around the tet. Around any one vertex of the tetrahedron, there are 3 planes. Looking down on a tetrahedron from above, we see 3 faces and 3 edges. There are these 3 edges and 3 faces around any one vertex. That seems very symmetrical and nice. You say that is logical. How could it be anything else? But if we think about it some more, it may seem rather strange because we observe 3 faces and 3 edges from an inventory of 4 faces and 6 edges. They are not the same inventories. It is interesting that we come out with symmetry around each of the points from a dissimilar inventory. All right, so one interesting thing about the tet, even though we have 2 eyes, if we're looking at it, either you're looking at it, I'll try to get the angle on the camera. So if you're looking at it from the top, or there really is no top or bottom, but if you're looking at it from this way, you see kind of a triangle. So you see 3 faces. And then the other way to look at it is that way. So here you only see an equilateral triangle. That's like seeing 1 face and 3 edges. And then here you see 3 faces and 6 edges. So that rotation is going to come into play a lot because these things are physical, so they're in a perspective. I'm not even sure how many places that kind of a subtle shift in perspective will matter, but it's like maybe a tilt shift or something with a crystal, with 2 perspectives on a crystal. So one perspective, you can see the whole thing, but you can't get depth. And then the other one, you just see a 1/6 of a facet. I don't know, but that's how the 2s and the 3s come out. And so he's saying it's crazy that you get symmetry, even though there's actually, depending on your perspective, you're going to see like radically different things. You're going to see a 2-dimensional thing, allegedly, an equilateral triangle, or you're going to see something that very clearly has depth. And just classic synergetics tone. It's symmetrical and nice. So it's argument by appeal to symmetry and nicety. So who's going to contest on either ground? 5. The tetrahedron is the first and simplest subdivision of universe because it could not have an insideness and an outsideness unless it had 4 vertexes and 6 edges. There are 4 areal subdivisions and 4 interweaving vertices or prime convergences in its 6-trajectory isolation system. The vertexial set of 4 local event foci coincides with the requirement of quantum mathematics for 4 unique quantum numbers for each uniquely considerable quantum. All right, very interesting. The TET is the simplest and first subdivision of universe. Once you get 4 things happening, you get an actual system that's enclosed inside and outside. Before, it's just a noodle. It's just 3 things that are waving around in the soup with any other 3 that you could draw. Once you have TET, you have in and out. And so that's why it's the minimum. It turns out when it comes into existence, or at the moment of it coming into existence, it has 4 vertices, 6 edges, 4 faces, 1 volume. 4, 6, 4, 1. Other shapes have different numbers, but the TET is 4, 6, 4, 1. So that's what it's an isolation system. It's the first isolation system. Little tetrahedral bunker. Domes above ground, tetrahedra underground. So it's an isolation system, and it has the 1s and the 2s and the 3s. It has all the prime convergences that you want to see. Those 4 local event foci, so 4 lightning strikes or 4 star bursts or 4 social relationships, 4 people with the relationships, coincides with, now, Jason Larkin, someone else, fact check, please. I haven't taken some quantum in a long time, but with the requirements of quantum mechanics, that for 4 unique quantum numbers, that there be basically 4 unique quantum numbers for each uniquely considerable quantum. So it's big if true. If it's true that nothing quantum exists without 4 exact things, like a tuple of 4 spin or something, and it really is that it requires 4, it would be huge. 6. With 3 positive edges and 3 negative edges, the tetrahedron provides a vectorial quantum model in conceptual array in which the right helix corresponds to the proton set with electron and antineutrino, and the left helix corresponds to the neutron set with positron and neutrino. The neutron group has a fundamental leftness, and the proton group has a fundamental rightness. They are not mirror images. In the tetrahedron, the 2 groups interact integrally. The tetrahedron is a form of energy package. All right, so there's a couple steps here that are implicit, and they're, again, it's like a total forest with where all the stuff is laid out in the text. Maybe one day we'll have a better system for cataloging it. We're downstream of the TET being the one that we want to focus on. It's clearly the minimum unit that's important, so we're going to be on TET life. And now there's this operation that we can do with the TET where we actually decompose it, not into like a little Sputnik in an equilateral triangle, like lifting the top off, or, I mean, again, not the top, just in this up and down world. I'm just referring to top and bottom and stuff like that. But it doesn't have to be that way. So with the wireframe, we can break it down with 2 Z's that are like intercalated. Now, the reason why the Z is chosen, there's a few, or I don't know if you want to call it a Z. It's on this image right here. But there's a few things about it. First off, each of these 3 edges, it conveys, if it were made of steel and were fixed at our spatial scale, it would recapitulate all of the vertices location relatively. So it's like DNA. Like you have 2 strands and you split them, and then they each can recapitulate each other. So DNA structure had just been crystallized and sort of gotten to a good understanding in the early 50s. So Bucky was like all about the DNA conceptually, and he understood that a TET could have this like DNA operation where it separates into 2 Z's and then 2 zigzags, and then each of them, one would be positive and left-handed or positive and right-handed, one would be, whichever side, could go with different correlations, but we can think about why. Each one would recapitulate each other with a DNA-like relationship. And then it's like, okay, well, would all the edges have positive valence or negative? How are we going to have maximum yin-yang, maximum coherence with the positive and the negative, aligning and counterbalancing so the net charge is 0? It's pretty clear one has to be positive and one has to be negative. Or you could probably have like a plus minus plus or a minus plus minus. I don't know if there's some weird quark stuff there. But the point is, there's this zigzag decomposition that still captures the TET, and it can regenerate the TET with only 3 out of 6 edges like a DNA strand. And then because the TET is an energy package, which is discussed a lot in the energy module sections of Synergetics, these are like the traces of energy that seal in the volume, perhaps. And also it introduces chirality. So we started with something that's totally symmetrical, and then it's actually pretty interesting that when you separate this thing that's totally symmetrical, you get chirality. Because if you have a cube, I don't think you can do a chiral generating maneuver on it. Maybe someone has done that. But pretty cool that with the tet, you just separate a couple of the joints, or just separate it conceptually, and then all of a sudden you have this interbalanced chiral system. 7. The tetrahedron is transformable, but its topological and quantum identity persists in whole units throughout all experiments with physical universe. All of the definable structuring of the universe, universe, is tetrahedrally coordinate in rational number increments of the tetrahedron. So how could there be a partial number in the real universe, right? It's H2O, it's not H pi O, as Bucky would say. It's actually finite things. And so if we know that the minimum finite thing is a tet, then universe, which is a finite set of tets, is finite. It's a definable thing. And the tet metaphysics are, he's suggesting it's how it's going to be throughout the whole universe. So seems pretty fair that geometry might be pretty similar. But again, if geometry is in the eye of the beholder, maybe it's not the same around the whole universe or even in the same place through time. 8. Organic chemistry and inorganic chemistry are both tetrahedrally coordinate. This relates to the thinking processes where the fundamental configuration came out as a tetrahedron. Nature's formulations here are a very, very high frequency. Nature makes viruses in split seconds. Whatever she does has very high frequency. We come to tetrahedron as the first spontaneous aggregate of the experiences. We discovered that nature is using tetrahedron in her fundamental formulation of the organic and inorganic chemistry. All structures are tetrahedrally based, and we find our thoughts resolving themselves spontaneously into the tetrahedron as it comes to the generalization of the special cases that are the physics or the chemistry. All right, this last one is what I'm going to start with here. All structures are tetrahedrally based. This is almost like a statement of faith or a dogma, or it's an axiomatic view of the world. Now, you could think it has support or not, but whether you're the kind of person who thinks that that statement needs support of some type or another or not, once you take this tetrahedra pill and you think that really all structure must be tetrahedral based, not triangle based or edge based or point based, but tet based, then if that's truly who you are from inside to outside, thought will spontaneously resolve into tetrahedral thinking. So that's the geometry of thinking, is having the deep prior that things are really tetrahedral. So using our kind of abstract ability to say and convince ourselves that things really are tet all the way down and up. And then any special case, we think tet first. Okay. Organic chemistry and inorganic chemistry are both tetrahedrally coordinate. Well, this is related to one of many things, is the carbon's geometry. Single bonded carbon, carbon with 4 bonds is tetrahedral, CH4. It's like the carbon is in the center of a tet, and then it has the 4 hydrogens that are equally repulsing each other, and they're at the edges. Now, carbon can also engage in different kinds of bonding, and that's where these things kind of come into play. Like, this is almost, I wonder if this is like one of the orbitals of a multiply bonded something. Or maybe there's some deep relationship with the way that a triple bond does look like that, kind of. So that's the tet, and that's the tetrahedral coordination of carbon, but there's other tet related symmetries. Again, thinking and metaphysics is size independent, because like a triangle is just 3 points. So it's size independent, it's metaphysical. It's not about any specific little iron triangle you build. It's about the idea. The specific thing would have to be composed of structural tets. Is there a book with a visual of the DNA concept, Heather Strong, in the YouTube chat? So the idea of just DNA unzipping and then being recapitulated is in almost every intro bio course. If you looked up DNA replication, that would show the unzipping of the double helix of DNA and then the recapitulation with a DNA synthase enzyme. So size is independent, is related to physical things, but then metaphysics is size independent. And we don't really use the word size as much because we're actually talking about tets. So we can talk about the frequency of the tets. And things that are higher frequency, they look smoother and smoother. So if it was like a wave that has a low frequency, then it looks like it's something you can almost trace out. If it's too low, then it looks flat to you. But then there's this intermediate range where you can actually see it or observe it. And then if it speeds up too much, it's faster frequency, it's higher frequency, and then it looks homogeneous again. So like light, 400 to 700 nanometers visible. So we only see the tiniest little fraction of the light spectrum of the photons. And we're going to take that kind of photon frequency, from radio to Wi-Fi and 5G and all that sort of stuff to photons. Now let's think about spatial frequency. Like a geodesic dome, this is a one frequency tet. But if it was made up of another subdivision or part of a larger thing, it could be part of a higher frequency shape. And so when we think about physical frequency, it turns out that smaller things are faster, which is kind of cool because that's what comes up a lot in active inference is like smaller things have a more rapid modes. They get averaged out and aggregated through collective behavior into larger, slower modes. So that's related to actually synergetics of Hermann Hakan, which is interesting because I don't know how Hermann Hakan's synergetics was related to Bucky's synergetics. There's actually a ton of overlap, but it's something I'd want to learn from a Hakan synergetics scholar on. So small things have high frequency. The cesium that now defines the time, that has a vibration of like many thousands of times per second. So it's better than a slower frequency thing that might have a higher error rate. And we got to TET because it was the first spontaneous aggregate of our experience. Because remember, we got there by discarding irrelevancies and coming to TET, not by saying that TET was constructed out there in the world. So we kind of build TET, we get to TET by subtracting irrelevancies. Not trying to find the relationships and, what if this drug goes to this protein and what if that cures this disease? We're going to start with system, start with the universe, draw down and understand where the TET is arising. Heather writes, does Bucky have a book where he talks about this DNA concept? I meant it could be. I'm not thinking of any specific image when I mention the DNA splitting. I'm sure he talks about DNA so much that somebody has to have made the image, if not him, then somebody else in another book or presentation. But if anyone knows, they can leave a comment or contact me about it later. But I didn't make an image. It could be something we could look at with an image in a future talk, but especially if someone could show me someone else's so I could highlight their work. We are at all times 9, seeking how it can be that nature can develop viruses or billions of beautiful bubbles in the wake of a ship. How does she formulate these lovely geometries so rapidly? She must have some fundamentally pure and simple way of developing these extraordinary life cells at the rate she develops them. When we get to something as simple as finding out that the tetrahedron is the minimum thinkable set that subdivides the universe and has 6 relatednesses, and that the chemist found all the structuring of nature to be tetrahedral, in some case vertex to vertex, in other case interlinked edge to edge, we find as our thoughts go this way that it is a very satisfying experience. What more could a sense-making human want than to be properly informed and satisfied? That's kind of where Bucky's coming from here. Now let's think about this organic and inorganic chemistry are tetrahedrally coordinate, and then this topic of the chemist finding all the structuring of nature to be tetrahedral, in some cases vertex to vertex, in other cases linked edge to edge. So this is also related to Arthur Loeb, who in the book, you can see on the cover, Arthur Loeb with a preface and a contribution. So there's a crystallography related section that Arthur Loeb, who was a crystallographer, contributed a lot of work to. And thinking here with the organic and inorganic. So the carbon and the tetrahedral coordination, people are like, okay, I kind of got that with the tetrahedral carbon and with organic life and things like that. But what about the so-called cubic face-centered crystals? Or what about the geometries of molecules and crystals that look like they're on the graph paper? They look like they're in the 90-degree world. How are we going to explain those? And what he's suggesting is that when you do space-filling shapes, we're going to talk about space filling maybe another time, but Tet doesn't space fill alone. So it turns out the tetrahedron is minimal system, but actually there's other kinds of shapes that are needed to co-tessellate through crystal space. And when you make those synergetic all space filling, so not just space enclosing, this was a great point by Kirby Erner on a comment on my last YouTube video. Space enclosing is highlighting this inside outness and the in and out. But all space filling is referring to a tessellation or a co-tessellation that can just go on like graph paper, but in 3 or more dimensions. So in the all space filling synergetic options, kind of the floor patterns that you got for synergetics to fill the room, fill all space, those recapitulate so-called cubic geometries, whether you choose to think about vertex to vertex or think about it like here we thought about methane with the carbon in the center and pointing out to the 4. But also we could have another one with a different shape co-tessellating and then the atom at the vertex and the edge as the bond. And it turns out that when we do that, there's actually a whole nother range of structures, because the CH4 tetrahedron and the diamond tetrahedron, all space filling, of course, it's actually a little bit reading too physically into it. It's very tensegrity based, it's a great entry point to think about the diamond and the CH4 as the all space filling in the minimal system of carbon. But synergetics in chemistry and quantum is about a lot more than carbon. And it has to do with a lot more geometries than the literal tetrahedral with the atom in the center and the edges going out. Because where'd you get those little short lines, the bonds, and what's their length? And people go, oh, I don't know, because I thought the edge had a length 1. 1 times 1 times 1 is 1. So there's a lot to learn there, but most focus has been on, of course, diamond, methane, and C60, Buckminster fullerene. And then some of those principles got abstracted to a little bit more macro level with the viral work, which Bucky was very excited about and is now pretty interesting in light of what's happening now. So it's pretty interesting that he's talking about viruses as being super fast and super small, and therefore we need to get in touch with small things in order to think about how to outsmart these viruses, because they go fast, but we have a slower but a more comprehensive sense-making ability. So how does the slower ship make light or make navigation when there's changing uncertainty and environmental variability and you're navigating with a big ship? And then if you have just a sailboat, then you just have a rudder. So that's like level 1 cybernetics, is you with the rudder, and you're steering the rudder and you're trying to figure out how to tack and zag and stuff like that to go uphill. There's uncertainty. But when you have the ocean liner and you have a system that's too big to fail, then you need to not have just the rudder, but actually a trim tab, because the rudder is too heavy to turn itself. And so the trim tab is this second level cybernetics that's related to guiding the guiding mechanisms of the ocean liner. And the trim tab strategy isn't the rudder strategy. It's very obviously not, because the trim tab is the one that's actually upstream of the rudder's lower dimensional behavior at a lower frequency. And maybe there's trim tabs all the way down. But certainly there are systems that you only need a rudder for, like a sailboat, one-person sailboat. And then there's systems where there might be other ways of having 2 rudders or something like that. But at some point, you need a modeling navigator who is making the best with the technology they have, like trim tab, to make your rudder more agile. But also, that trim tab strategy is not obvious. So it can't just be the rudder strategy, because then you could just have the rudder. And this is kind of like in complexity when we talk about simple rules and so-called complex outcomes, which it could just be simple rules, leave it at that, right? And his observation is viruses replicate so fast, and this was a period in the 40s and 50s when they were just like, whoa, it goes from one little T4 virophage into 10 billion T4s in half an hour, so its doubling time has to be just something amazing. And so these small, fast viruses, and then the way that when the ship goes through the water, it makes bubbles so rapidly, and they're stable, at least to our experience. So there has to be a way to make so-called order out of disorder and do it fast. How does she formulate these lovely geometries so rapidly? It's kind of like a Tiger Tiger by William Blake. But how do you get these remote teams to form so rapidly? How do you get the good ideas to form so rapidly? How do you get the good innovations so they can actually be deployed to happen rapidly? It's good to be rigorous, but actually we can do it the way nature does it. And so how can we get at that pure way of thinking about it? And then I copied 620.06 figure here. The caption is tetrahedron as a vectorial model of quantum. The tetrahedron as a basic vectorial model is the fundamental structural system of the universe. The open-ended triangular spiral as action, reaction, and resultant, proton, electron, and antineutrino, or neutron, positron, and neutrino, becomes half quantum. An association of positive and negative half quantum units identifies the tetrahedron as one quantum. So it's kind of like the quantum of solace or something like that. Like it's the oneness. It's not referring to the Schrodinger's cat or, some sort of wave particle thing per se. It's about the idea that there's a discreteness, and that's related to the photoelectric effect. And so when we think about the geometrical quanta, what is the smallest geometrical thing? Well, if you were a point-centered person, you'd say, well, the smallest geometrical thing is a point. An edge-centered person would say the smallest geometrical thing is the edge. A face-centered person says the smallest geometrical thing is a triangle. But in synergetics, we say the smallest thing is the quanta, is the tet. So it should have a volume of 1 and a mass of 1. Yeah. All right. Let's see. Okay. 10. All polyhedra may be subdivided into component tetrahedra, but no tetrahedra may be subdivided into component polyhedra of less than the tetrahedron's 4 faces. So basically, you can fill other shapes with tet by subdividing them. If you had another, like a cube, you could subdivide it in such a way. But no tet may be divided into another coherent polyhedra. You're just going to get another, if you pick another point internal to this tet, you just made a tet with a different dimensionality, but it's still a tet. 11. The triangle is the minimum polygon and the tetrahedron is the minimal structural system, for we cannot find an enclosure of less than 4 sides, that is to say of less than 720 degrees of interior or exterior angle interaction. The tetrahedron is a tetrahedron independent of its edge lengths or relative volume. In tetrahedra of any size, the angles are always sum totally 720 degrees. So again, just kind of highlighting that triangles are conceptual. Anything, if you have an iron triangle in your yard, it's made up of little tetrahedral iron molecules that you've clumped together in a way that looks like a triangle at that frequency. But it's not a triangle. That's a conceptual thing. And, sorry, a little cold. Tetrahedra is something that is both conceptual, that's why synergetics is the geometry of thinking, but also tetrahedra is the minimal physical system. Substituting the word tetrahedron for the number 2 completes my long attempt to convert all of the previously unidentifiable integers of topology into geometrical conceptuality. Thus we see both the rational energy quantum of physics and the topological tetrahedron of the isotropic vector matrix, rationally accounting all physical and metaphysical systems. Big. Maybe we'll go into these sections another time. But Bucky was on a long attempt to convert all of the previously unidentifiable, so unreachable, integers of topology, like 1, 2, 3, discrete things, nodes and edges, into geometrical conceptuality. So could we link geometry and topology in a way that was not just in the hyperdimensional, but something that was actually across scales and probably had a few different features as well? I'd be curious, like, do mathematicians think that geometry and topology are unified? What about information geometry and message passing, like information topology? Thus we see the rational energy quantum of physics. So when he gets the oneness and it comes into existence with that 1464, he's like, we got the numbers, we got the quantum, we got the topological minimal system, and it turns out it has to do with this isotropic vector matrix. So it's all space filling. And so if you can go subsystem and all space filling, so that's like 1 little subunit of the crystal and total crystal, maybe through space and time, if you can go macro to micro and you define the macro micro and you get the quantum and you also get this other stuff like the 1 and the 2 and 3, and then you can build all the other numbers and you can go to anywhere in the grid, and then you can make it a higher frequency. If you want to go to a space that's not on a vertex or not on an edge, you can just make it denser, and then you can go there just as easy as you could go anywhere. In fact, the higher frequency, the better the geodesic is. So the higher frequency the model, if it's accurate, the better your trip is. And the faster you're going to get there. And then there's a lot to say about that, but it seems like if that were your long attempt, then maybe he did succeed. Constant properties of the tetrahedron. 2. Evaluated in conventional terms of cubical unity, the volume of a tetrahedron is one-third the base area times the altitude. In synergetics, however, the volume of the tetrahedron is unity and the cube is threefold unity. Any asymmetric tetrahedron will have a volume equal to any other tetrahedron so long as they have common base area and common altitudes. So this last part is kind of like a little lemma or a corollary that's saying, like, if the triangle has the same base and height, then they have the same area. Or if the line has the same difference between the 2 points, they have the same length. Those are some of the most fundamental pieces of measure theory. So I don't know that much about that, but there's a lot of assumptions that go into measure theory. So if we're going to be measuring things, we want them to line up in a certain way. We need like the tet here to be translatable and scalable and linearly addable and probably a couple of other things. And then it's like, what will people say? Why can't the tet be a volume 1? Why can't this be volume unity? And they'll say, because the cube is 1 times 1 times 1, so it has a volume of 1. And then the tet fills up only a third of that. The other way, the synergetic way of thinking is, why would you base your volumetric comparisons off of the tet when just from first principles, the volume that you can get is obviously 1 with a tet? Just take the high ground because it's easy argumentation. And then you get the 60 degrees and everything else is just there. Among geometrical systems, a tetrahedron encloses the minimal volume with the most surface, and a sphere encloses the most volume with the least surface. All right, so a tetrahedron encloses the minimal volume with the most surface. Basically, if without denting the sides or adding more points, this is the minimal amount of volume to the maximal amount of paint needed, surface area. And this is kind of like bacteria, their surface area to volume ratio is different than a bigger thing. Just like an ant can pick up, it can pick up this much times its body weight. That's just because it's small. And then muscle strength scales linearly, and the weight scales at a superlinear because it has volume. So yes, relative to their body weight, smaller things are simply stronger, but it's not too much more than that. And so again, if we take tet first, then this is clearly the most surface area to volume ratio, because you can't have a smaller thing that has a surface area to volume because it doesn't have volume. And then the way that you can get the maximum surface area to volume is actually by like inflating the tet, which is to the sphere, because there's no shape that has more. If you take a little bump out of a sphere, then it's like taking up a lot of surface area and not actually adding that much volume. You'd be better served to distribute it equally across the sphere's growing surface, which is why they inflate that way. Maximum entropy, free energy principle. A cone is simply a tetrahedron being rotated. Is it? Sure. So it is. If you specify the 3 rays of that cone, then you 3 rays of the tet, and like the triangle, and then you say, well, now rotate that triangle around its center of gravity. It's another way to specify a cone. Omnidirectional growth, which means all life can be accommodated only by tetrahedron. Not sure, maybe the cone is like projecting out into the future, or projecting like a time cone. It's projecting out into evolution or phylogeny. And so then we can think about that not as like a radiating cone, but like a radiating tet with higher frequency phylogenetic branches. I don't know if there's been a tetrahedral phylogenomics model, but that sounds pretty chill. Section 5. There is a minimum of 4 unique planes non-parallel to one another. The 4 planes of the tetrahedron can never be parallel to one another. So there are 4 unique perpendiculars in the tetrahedron's 4 unique faces, and they make up a 4-dimensional system. So here's one of the 4Ds right there for us. So there's 4 sides on the tet. It's a tetrahedron. It's also a hexaedge and a tetravert and a univol, but it is also a tetrahedron. And those planes cannot be parallel. In the cube, in the perfect cube, you do get parallel planes. But these 4 planes on the sides are never parallel. So they're always unique. So you could always have a point inside or outside, and you could have that point in 4 dimensions. Now, it might be one more than you need. In fact, that 4th one is a degree of freedom. But you can identify with the 4, if you said, I have a point over here, its relationship to this one is this, its relationship to this one is that, you could triangulate, but you could tetralate. I don't know if there's a word for that. How could we not have a word for navigating via tetrahedrulation? 6th powering is all the perpendiculars to the 12 faces of the rhombic dodecahedron. All right. I'm going to take that one as true, that if you do 6th powering, something with the 12 faces. We'll go to this last set of figures on the TET and then go to the other section, 986. So figure 621.01, constant properties of the tetrahedron. A, the area of a triangle is 1/2 the base times the altitude. Any arbitrary triangle will have the same area as any other triangle so long as they have a common base and altitude. Here is shown a system with 2 constants, A and B, with 2 variables, the edges of the triangle accepting A. So here in this A, we're seeing that as the base is kept constant and the height is kept constant B, you can slide the top of that 3rd point and you get the same volume, same area, sorry. So same amount of paint to paint these triangles as you slide it even way off to the right. B, the volume of a tetrahedron is 1/3 the base area times the altitude. Any arbitrary tetrahedron will have a volume equal to any other tetrahedron so long as they have a common base areas and common altitudes. Here is shown a system in which there are 3 constants, A, B, and C, and 5 variables, all the tetrahedron excluding A. All right, so here's what's pretty interesting. You fix A and you fix B in the triangle. So on this part, I hope you can see with my mouse. Yeah, I think you can. And then as you slide the degree of freedom, this one free point, there's 2 things that are changing. 2 sides are changing. Well, there's the angle of the top is changing, and both the angles are changing. So all the angles are always changing because that's what defines the shape. So all angles are always changing. But also, you have 2 side lengths that are changing. Now, in a tetrahedron, you have to fix 3 things instead of 3 things on the bottom, and then you have to fix the height with C. So you have A, B, and C. So you fixed A and B just like the triangle. That's why it's A and B. And then you have to fix one more to get to specify the bottom of the tet, and then you get the degree of freedom on the top. And it turns out that as you do that, if you keep the altitude constant, it has a constant volume, just like a triangle. C. As the tetrahedron is pulled out from the cube, why does that matter that it can have a constant volume? Because then you can know that you're still working with minimum system, even if the pieces are in like a very strange orientation. You can actually know that rescaled, it's still 1 at that correct scale, even if it looks very asymmetrical. They don't all have to be so beautiful like this brass one by Trevor. As the tetrahedron is pulled out from the cube, the circumference around the tetrahedron remains equal when taken at the points where cube and tetrahedron edges cross, i.e. any rectangular plane through the regular tetrahedron will have a circumference equal to any other rectangular plane taken through the same tetrahedron. This circumference will have twice the length of the tetrahedron edge. Okay, so as the tet, so we had the tet with side lengths of 1, and we're just going to give it a volume of 1. It's 1/3 of the volume of a cube. So instead of saying the cube has a volume of 1 and the tet has a volume of 1/3, we're going to say that the tet has a volume of 1 and the cube has a volume of 3-fold unity. And it looks in C like as you pull the tet in and out of the box of the cube, time cube, as you pull it in and out of the cube, you get squares. And then that's what it looks like. Like there's a way that it somehow is piercing that top side of the box and giving squares that might be like all the way. If it was a bigger tet, it could cover up the whole face of the square cube. If it was a tiny tet, or if it was only a little bit in, it'd be a tiny square. So maybe there's like tets in boxes doing this, not to be graphic, but then that is making little squares and big squares. Could be. All right, that's it for the tet section. 986, Demass Model scenario. All right, this will be the second section, and cool, it's been about an hour. So this is in 986, and this was recommended by CJ Fearnley in his Reading Synergetics essay that we took a look at last time. So it's cool that he recommended this as an entry point. I wonder what the numerology of 986 is. 10. Narrative recapitulation. The exposition herein recounts and recapitulates the original surprise and excitement of the progressive, empirically verified conceptionings, the family of relevant experimental evidence recalls, the modus operandi, the successive, only evolutionarily discovered inputs, and the synergetic comprehension of the omni-interresultant cosmic significance of these strategically employable, synergetically critical additions to human knowledge and their technologically realizable insights. All right, so it's kind of like, Bucky's submitting it to nature, and he's like, it's going to have impact. This is his impact statement. He's basically saying, I'm about to give a narrative exposition about how surprised and excited I was when progressively, not in that way, he empirically verified conceptionings, his thoughts. And what were those thoughts? They were the family of evidence he recalled and experiences he recalled at the right moments in time. Semicolon. That is the modus operandi. Here's how I did it. Here's the Google searches and the Wikipedia chains that I followed. Here's the edits I made on the document. Here's what I looked at to gain this information. Here's how that impressed on me. That's your modus operandi. So he's about to show us how he did it. The successive, of course, they were following one after another in his own experience. Only evolutionarily discovered inputs. Now here he might be using evolution kind of like development, because evolution would really be between generations versus development within a generation, but maybe he's talking about the evolution, not just his own life. And the synergetic comprehension, so kind of like totally the coolest comprehension, grasping, physical, tangible, tactile, and the omni-interresultant, so every possible relationship and how it's all interrelated, cosmic, of course, big scale and tiny scale, big significance, high impact, because they're strategically employable or deployable. You can actually use this strategically. That means that because it's good, true, beautiful, useful, etc., it's totally critical to add that to our knowledge and what we can do with tech. It's not just silicon wafers. It's also synergetic tech. Elementary school definitions. My first mathematics and geometry teachers taught me games that I learned to play well enough to obtain swiftly the answers for which they're only axiomatically argued assumptions called. Webster's dictionary states tersely the definitions of the games they taught me. Webster's definitions are carefully formulated by leading academic authorities and represent up-to-the-minute consensus of what the educational systems assume geometry, science, and mathematics to consist. So, how many of these Bucky childhood stories are true? All of them and more, let's just say. But he's remembering that the teacher would go, well, that's going to, when the teacher draws a triangle and says, this is the triangle, it's the minimum polyhedra. And Bucky goes, isn't that just made of little crystals of chalk that are actually tetrahedral? And actually it's just a very high frequency line of oscillating things that are actually smaller. What do you mean how could a triangle exist if it doesn't have any volume? And so he was allegedly asking these questions, and he's saying they could only appeal to authority. And the appeal to authority was the so-called leading academic authorities. And they defined their game in a way that we'll get to in a second, but Bucky wasn't happy with just appeal to authority and axiom. He wanted direct experience. Webster defines geometry, 22, as the mathematics of the properties, measurements, and relationships of points, lines, angles, surfaces, and solids, none of which we can observe, can exist experientially. Ergo, science verifiably, independently of the others. Ergo, they cannot be isolatable properties or separate characteristics. So this is pretty interesting. Remember that the tetrahedron, aka the hexaedge, the tetravert, and the univol, that's an all at once. That's quantum. Now, he's going to take that quantum and literally say it also applies to quantum mechanics, so-called, because clearly that's happening at a smaller, discrete level, but also other quantal events. But now let's think about abstract quanta. Can an edge come into relationship without points? No. Can a face come into relationship or existence without edges? No. Now, can points or edges or faces come into existence without a tet, IRL, in real life? No. So, they're dimensional descriptors of a tet. 1, 4, 6, 4, 1 volume, 4 faces, 6 edges, 1 vertice, volume of 1. That's just how we're going to say it. That's the tetrahedral stack. That's what it means to be a tet. You get the whole tuple, not just volume of 1 or not just 4 points. Because even if you define it in your Python program as 4 points, instantly you entail a volume. And so basically Bucky's taking that so seriously that you can't talk about the relationships of points, lines, angles, surfaces, and solids unless you're tetrahedra first. It doesn't exist without these are not independent dials you can tweak because space has a shape and it's tetrahedral. 23. Physics has found no surfaces and no solids, only localized regions of high frequency, self-interfering, deflecting, and consequently self-nodding energy events. These self-interference patterns occur in pure principle of ultra-high frequency intervals and on so minuscule a scale as to prohibit intrusion by anything so dimensionally gross and slow as our fingers. We cannot put our fingers between any two of all the numbers occurring serially between the integer 1 and the integer 2 trillion. 2 trillion as aggregated linearly in 1 inch. This is the approximate number of atomic domains, the xth illion per second electron-orbited atoms' individual spin-out domains, tangentially arrayable in a row within an experience inch. It's just water. So, the approximate number of atomic domains. So we're talking about 1 inch, and we're thinking about the number line 1 to 2 trillion, and he's just throwing it out there. It's kind of like a Fermi estimate that there's 2 trillion atomic diameters in an inch. So an inch is something that we can grasp, just like a foot or something like that. Like an inch is something you look at your finger and they're a couple of inches long. So an inch is a length that we can grasp. Literally, we can pick it up, we can comprehend it, we can compare it. We know that some fruits are 1 inch and some fruits are 6 inches or something like that. But it's hard for us to put our finger on, literally to grasp. We can't pick it up, we can't comprehend it, so we can't get it. 1 2/trillionth in 1 inch. When I'm dissecting an insect, it's smaller than my fingers, and I can use forceps. But that only takes one by a factor of a couple. It can make you manipulate something instead of that's half an inch, something that's 1 millimeter or something like that. But it can't take you down to the atomic level. So it looks continuous. And then also just note that it's not the indivisible atom model of the early atomists, or later atomists for that reason. It's the spin-out radius of the electron-orbited atoms. So it's like the repulsion domains that he's talking about. So we're not talking about atoms as little modules or something like that. This is like, he's talking about even the atom as a dynamical system that's based upon these tensegrity and synergetic principles. And basically, this is what we've talked about a little bit today, which is kind of that very fast, rapid, small things look homogeneous or invisible. Like the frequency of paper is very high. The irregularities of paper are, they're at a level that's we can't really see. But when I put the piece of paper under my microscope, then it totally looks ragged, especially for some kinds of paper. And so similarly, there might be a curve that looks smooth when you're 100 feet away, but then you walk up closer and you can see it's not. So that's very finitist. Within each of the electron-orbited spheric domains, the respective atomic nuclei are centered as remotely distant from their orbiting electrons as is our sun from its orbiting planets. Within each of these nuclei, complex high-frequency events are occurring in pure principle of interrelationship. Definitely for another day to go into the nuclear fission synergetics, but he's basically saying, I don't know if this is quantitatively true, but it's kind of just conceptually true. The sun, with all the planets in their spin-out, is like the nucleus with the electrons in its spin-out. And I remember hearing things like, if you scaled up the nucleus to the size of a baseball, then the electron orbital would be like the whole baseball stadium. So I don't know the exact numbers on that one. Obviously, it depends on the shape. But then he's saying, so that's kind of what's happening with the spin-out of the electron. And one question I have here is, how does Bucky think about the wave particle? How do we think about the spin out of a particle, but also like the field without having any spin out of any object, just a projection field? So just the wave. So we need conceptual stuff to do better, to think about small things. Within each of, and so then the nuclei are in the middle of like that kind of spherical thing, but again, it's still finite. How do you see through a solid glass window? 25. Light passes through glass. Not all wavelengths. Light is high-frequency radiation passing unobstructedly at 700 million miles per hour with lots of time and room to spare between the sets of energy events that constitute the atomic event constellation known as glass. In lenses, the light caroms off atoms to have its course deliberately and angularly altered. So similar idea, like if you have, this is kind of the early Rutherford experiments, I believe, where it was a single layer of gold foil. And then electrons or some other type of high energy thing was shot at this gold foil. And then they did like almost 360 degrees with the detector. And so almost all the high energy stuff went straight through because the solid part of the gold single foil is so tiny. So like 99.9% of it makes a solid deposition just straight on the other side of the foil. But then a small fraction are deflected, et cetera, et cetera, et cetera. And so you can calculate that there's something hard and spherical, now not a sphere because it's actually finite how many of these protons and neutrons are in there. And then they have their own quarks in their own dance, but they have their own spinouts. So they constitute at the next level up a little bit of a stable structure that can come together. Tet, remember separating it into the positive and the negative chiralities. That takes up a tiny bit. And then Rutherford's experiment was able to calculate like, whoa, a tiny fraction does bounce almost all the way back towards us. So it has to have a face towards almost us. And it has to have a face that's almost that way. And that way, and then it deflects slightly. And then most of it go through. So by doing that, you could say about how big is the nucleus. And about, so that's how much of the foil percentage-wise it takes up. And then what rough shape is it? And they found out it was roughly spherical. And then he's saying basically glass is a material where the photons just pass right through for wavelengths that it is transmissible for. And then he's appealing to another kind of meta property of materials, which is like lenses. So it's not just that glasses pass through light, they actually all perform distortion. And then if you just make it in no specific way at a uniform thickness, then it passes through with an equal amount of diminution across the surface, whereas you can make it like a magnifying glass, or you can make it like a Fresnel lens. Okay, so that was geometry. And he's basically saying, yeah, my teacher was like, look it up, Bucky. I think that's what happened at 21.5. The teacher's like, look it up in Webster's. That's where all the smart people went, right? And he sees geometry as all these things that can't come into existence differentially. And so it makes him question physics from physics. If that's how we're going to ground with empirical experiments, how can we ground our geometry in something that doesn't even have a basis in physics, where there are no surfaces and no solids? So if we're going to have geometry, it should be kind of derived from generalizations of what we do see rather than fantasies on what we know can't exist or something like that, like sphere packings of a different kind. We know that when we pack spheres, they fall in a certain way. But if you said, well, I wish it were different and I want all my geometry to be different, it's not going to be useful in the sphere packing world we're in. Now, okay, so that was geometry. So Bucky was like, because of physics and what they found, geometry, as Webster defined it, is disinfo. 26. Webster's definition of mathematics is the science of dealing with quantities, forms, etc., and their relationships by use of numbers and symbols. And then he says 27. Webster defines science as a systematized knowledge derived from observation and study. Now, the fact that he doesn't go on a little rant here, a little tear, I think he's actually fine with these terse definitions of mathematics and science. He just thinks that the geometry part is being disinformed by the Euclidean flat earth delusion. And so geometry needs to be reformed. That's why it's the geometry of thinking, not the mathematics of thinking, not the science of thinking, not the art of thinking, not the design of thinking, but the geometry of it, because that's the part that isn't in line with our direct experience. We know better now. We can do better with geometry. And then it's yes and with all these different geometries. We're building on from points of contact and future bridges we'll make with all the previous geometry. It's all good. It's all been part of our critical path. But we really need geometry to be synergetic rather than Euclidean, and people need to be educated more integrally in synergetic geometry if there are going to be certain kinds of synergetic cultures. 28. In respect to those definitions, I was taught between 1905 and 1913 at the private preparatory school, then most highly regarded by Harvard, that the properties of a point are non-existent, that a point is non-dimensional or infradimensional, weightless and timeless. The teacher had opened the day's lesson by making a white chalk mark on the cleanly washed off blackboard and saying, "This is a point." I was next taught that a line is one-dimensional and consists of a straight row of non-dimensional points, and I'm informed that today, in 1978, all school children around the world are as yet being so taught. Since such a line lacks three-dimensionality, it too is non-existent to the second power or to the square root of non-existence. We were told by our mathematics teacher that the plane is a raft of tangentially parallel rows of non-existent lines, ergo either a third power or a cube root of non-existence, while the supposedly, quote, real cube of 3 dimensions is a rectilinear stack of those non-existent planes, and thus therefore must either be a fourth power or a fourth root of non-existence. Since the cube lacked weight, temperature, or duration in time, and since its empty 12-edged frame of non-existent lines would not hold shape, it was preposterously non-demonstrable, ergo a treacherous device for students, and useful only in playing the games of deliberate self-deception. Since it was arbitrarily compounded of avowedly non-existent points, the socially accepted three-dimensional reality of the academic system was not derived from observation and study, ergo to me was utterly scientific. So we're going back to Bucky with his experience in the classroom, and he looks at mathematics. He's like, okay, I like that. He looks at science and he goes, okay, it's about observation and study. I can do that. Then geometry just riles him up because they're being told that points are the starting point, right? Not the starting volume, the starting point. RIP, Synergetics. Because the starting point is a point. It's how people talk and think. It's the geometry of language and the language of thought. And so then they're like, yeah, it's a point, but it doesn't exist. And then, 20% of the children go, okay. And then 80% say, what? It doesn't exist? And then they go, okay, now there's a line, and it's like an infinite number of the non-existing thing. Wait, how is it an infinite number of the non-existing thing? What about 1 to 2 trillion atoms? Those are finite. There's really there. No. It's the second order of fantasy. And then 80% of the children don't pass that level, and 20% move on. And then it goes on until they get to the cube, which is the one that should exist. Because this is the one that you can have in your building blocks, and you have when you're a child, and in our disinfo architecture. We can have a cube. But you got to get there and resolve this cognitive tension between, well, the cube's real, it has volume, 1 cubic centimeter, 1 gram, it's all about the cube, and that's the volume, and it gets the 90-degree angles. But It's made up of an infinite number of points that make up an infinite number of lines that make up an infinite number of planes, hyperstacks, and then you just get the cube. So 0 to 1 isn't even baked in. And so one way of thinking about Bucky's parable here is children are schooled, and part of their natural curiosities are tweaked to deal with this system. And so when you have to resolve that tension that's fundamental between the infinite number of lines in a plane and so on, it's abstracted, and so it disconnects from our experience, where there's nothing that's infinitely small, like even tiny stuff, it's still there. If it's not there, it's in your mind. It's metaphysical. It's non-physical. For the things that are comprehensible, graspable, observable, things that you can actually understand, talk about, communicate, they're tangible and finite. And so Bucky is going hard on that and revealing that when people are brought up in this system where it's cubes all the way so-called up, first they have you doing geometry with a cube. They got you in the crib that's a cube with the parallel lines in the cubic room. Then they get you in the preschool with the blocks, with the ABC blocks, the fundamentals, blocks, starting point. Then they teach you this stuff about the basic shapes. Why is it 1/2 base height? What is a triangle? How does it have a weight if it doesn't have height? Oh, well, height is imaginary too. Okay. Well, some people can get it and some don't. And so this is really a pretty powerful section of Synergetics, because he's basically saying, I was with you on 2 out of 3, but it's the geometry that has to change. And that is all we're going to do for this section today. But then it talks about, in the rest of this Demass scenario, he talks a little bit about abstraction. He then talks about the way that the Greeks, different groups of Grecians, utilized different axioms and different tools, and how that had consequences with history. He traces the Greek story a huge amount, which maybe we can get to another time, and then goes from the Ionian to the Euclidean Greeks, and brings us to our unfamiliarity with Tetrahedron. And then this is allegedly a robot camera photograph of Tetrahedra on Mars. And the NASA scientists revealed their unfamiliarity with Tetrahedra. So that's kind of how he concludes that little section. But basically that, and then we can talk more about characteristics of Tetrahedra in a higher frequency. It's pretty cool. But this Demass scenario is basically like, starts with Bucky as a child having this flashback to the teacher telling him to go look it up, kiddo, for mathematics, science, and geometry. And that kind of sparks his interest in unifying his experience with geometry and topology, and just never falling for an appeal to authority, or never falling for using language unintentionally, or using his actions or his thought unintentionally. So really pretty educational section. All right, well, pretty nice discussion today. Thanks everybody who watched live or who is watching it in replay. We had the spirit of family and navigation through paradox, you could say, and talked about 2 nice components of Synergetics. One was 620, tetrahedron. Nice. I had my filled one unit of brass. This is now this is like the meter stick that was a metal thing. This is going to be like the unit, this is 1 pound. Then little tet, and then I have a couple of these bigger tets. They're fun too. So we got to look at how some things like the inside outing, which changes the chirality of the top. So you got inside outing, and about how maybe double bonding works, and about minimal system, inside out, going in and out across the Markov blanket. And that's pretty basic, like basic research synergetics, like at the fundamental or at the most inner layer. And then also this Demass model scenario kind of looked at that tetrahedral thinking from a different perspective, which was a very personal perspective of Bucky recounting a childhood memory, and then in a reverie, merging into a story about history, concluding in how that led to the cubic psyop. And then we have the book and the vocabulary and some of the tools to work out of it. through the points of contact, like wherever there's a square, we can actually build on that in the yes and. It's not that we're countervailing the square. It's just that's one of the relationships, sodium chloride crystals with a face-centered cubic or whatever it's called. We can get the cubes from synergetics, but we don't get synergetics from cubes. So that's really important and pretty fun talk. So again, thanks for those who are listening, and I always appreciate people's thoughts and comments or suggestions, whether somebody with a different expertise or perspective wants to join these discussions. That'd be awesome. So cool. Thanks everyone. Tetrahedra out.